to find our sessions on my YouTube channel under the live stream section. There is one user on us right now whose username says Zoom user. So you're the only person that I don't really know. Just send me a DM so that I can give you attendance credit. Let's see. So, okay, I got you. Okay. All right. Okay. Let me share my screen. I got you, Mr. Henderson. Hey, Mr. Henderson. I just had a flashback to Dennis the Menace. Hey, Mr. Wilson. Let me share my screen, start the broadcast, and we'll get the party started. So, all right. So I'm assuming everything is working. I didn't really do anything different than what I normally do. View as a single page. Let me see. So, gentlemen, we are like rapidly entering the home stretch, right? So when I was kind of loading my notes for the day, and I was glancing to see how much more of like new stuff that we have, we only have 4 seconds remaining. Like we have this week of new content, and then we're going to finish out the new content next week. All right, so we're pretty much at the end. So I just say that to say, this is a good time to kind of try to get as many of your assignments that you can access on Pearson. Try to get as many of those assignments in order as possible. If you are, let me see. So if we're going to do the last of the new material at the end of next week, then the week after that, you can anticipate exam 2 over chapters 3 and 4. All right. So, that'll be here shortly, like rapidly. So just kind of gear up for that. And then again, this is a good time to try to improve like any old scores or whatever. And so if you are going back and like doing old assignments, I would encourage you to prioritize your exams first. I know this is only our second exam. We're going to have 2 exams and a final ultimately. But again, unlimited attempts, the system is set to take your highest score. There's only a 5% late penalty. So like if you have old assignments whose scores are less than 95%, you're welcome to redo them and improve your score, which is huge, right? In the order of priority for doing old assignments is like the highest priority are your exams, because that's where you're going to get the most bang for your buck, the least amount of work and elicit the most amount of change. Once you've gotten your exams wherever you want them to be or wherever you can get them to be, then the second order of priority are going to be quizzes. Quizzes are like usually about 5 questions at most, and they have the same weight as the homework. So all that work for the homework is equivalent to the same weight for the quizzes, where the quizzes are a lot less work, right? So first priority are exams, second priority are old quizzes, and then if you just have the time and energy, the last priority is the homework. The homework is a lot of work for minimal points. The homework is really there to kind of get you ready for the exams. And so once you have access to the exams, again, the exams take priority. As usual, if you have questions, are there any questions before we kind of go forward going once, going twice? I hope everyone has had a great weekend. As usual, if you do have questions, feel free to either type it in the chat or unmute yourself to get my attention and we can talk about it. And another kind of general rule of thumb is like whatever score you're going for, generally speaking, you want your scores, as many scores as possible, to be higher than that score, especially your exams, right? Because that has the heavier weight. So whatever grade you're trying to get out of the course, you want to try to get those assignments to get as far above whatever score you're going for as possible. Like not that I encourage people to just try to pass, but like if a student were just trying to pass, which is like a 70, 72, something like that, if you're making 70s on everything, you don't want to be in that position because you're not leaving any room for error, right? So as much as possible, you want to essentially just maximize your scores, because usually the score does fall shorter or less than whatever people are going for. So you want to try to create as much cushion as possible. Okay, so with that, we're going to continue in chapter 4 on integration. Again, the main idea behind integration is the reverse of differentiation, right? So chapters 1 through 3, where we're exploring taking the derivative and its applications. So now we're going to start with the answer and work backwards, right? Start with the derivative and see can we get back to the original function. And so today we're going to be focused on section 4.3, area and definite intervals. So I know we kind of explored some techniques for integration last time, and we saw how the area relates to like the integral, and that the area under the curve is the integral of the graph that we have, you know. Let's see. And I think we had like simple shapes that we were working with. So now we're just gonna kind of continue that narrative, or go a little bit deeper on that narrative of the area under our curve and integrals. We have a few objectives here. One, find the area. Let me check the chat real quick. Matter of fact, let me put it here. Missing anybody? Let me get these gentlemen. That's that one. So I do have my alerts turned off today. Okay, and the chat looks good. I was really just trying to check the chat. So again, a few objectives here. One, find the area under the graph of a non-negative function over a given closed interval. Two, evaluate. Two, evaluate a definite integral. Three, solve applied problems involving definite integrals. Okay, let's take a look at this. So the fundamental theorem of calculus: to find the area under the graph of a non-negative continuous function f over a closed interval ab. One, find any antiderivative f, capital F of x, lowercase f of x, right? The antiderivative is going to be capital F of x. The simplest is the one for which the constant of integration is 0. So I think when we were doing our integration before, we always had this plus c, plus this constant of integration, right? And again, whenever we have a candidate for our integral, we check it by taking the derivative. And so then the derivative of a constant is 0. So that's why we have this constant of integration. Then number two, evaluate the antiderivative using B and A. So the endpoints B and A, and compute f of B minus f of A. The result, or the antiderivative of f at B minus the antiderivative of f at A. The result is going to be the area under the graph over the closed interval from A to B. Okay. So example one, we're asked to find the area under the graph of this function over the closed interval as x goes from -1 to 2. So all we're going to do is take our integration like we did before, but instead of saying plus c, we're going to evaluate the antiderivative as x goes from -1 to 2. All right, so let's see this in action. This is this. Right. I don't know if that was this group or not. I think last time I dropped my pen and I got nervous, but I think it's somehow like it's healed and it's like kind of working back normal again. Let me see. At least that's last time I checked it was. So we want to evaluate the integral as x goes from -1 to 2 of x squared plus 1 dx. Okay, so this is basically what they're asking us to do. Okay, so all we do is take the integral like normal. So the integral of x squared should be what? X cubed over 1? I mean, over 3. The integral of 1 is just going to be x, right? Normally we would say plus the c, which is going to be our constant of integration, but because we have these endpoints, we don't need it. And let's do a quick check to make sure that when we take the derivative, we get back to the original. So then if you take the derivative, the 3's come down and cancel. We get x squared, and the derivative of x is 1. So this is good. So we want to evaluate this antiderivative as x goes from -1 to 2, right? So then all we're going to do, basically plug in 2, we get an answer. As we plug in 2, we get an answer. Then we say minus, we plug in the -1 and we get an answer, right? So we're going to say 2 cubed over 3 plus 2, that answer, minus -1 cubed over 3 minus 1. So when x is 2 minus when x is negative 1. Okay. All right. So then it looks like we get what? 8 over 3 plus, what is that, 6 over 3? Let me see. That's a negative 1 over 3. Okay. So then it's going to become plus 1 over 3. And then plus 3 over 3. Right? Getting a common denominator. Distributing that negative. So then 8 and 4 is what? Or 4 and 6 is 10. So it's 18 over 3. 18 over 3, which is what? 6. So the area under the curve, like if we were to graph this curve and draw vertical lines when x is negative 1 to when x is 2, the area under the curve with those endpoints is going to give us 6. It has a value of 6. That's essentially what it's saying. It felt like for a hot second somebody had their mic unmuted. Again, if you have a question, feel free to ask. It may have gotten answered. So, whew. Yeah, I don't know. You had to forgive me. I was good all day. I've been chatting on the phone. Like I took a nap earlier. I feel nice and fresh. And then as soon as I sit down, but I think it's because I'm looking down. You know, wherever the head goes, the body will follow. And I feel like wherever the eyes go, the head will follow. So then if I'm looking down, then my head goes down, then my body goes down, then I get sleepy. Right. I think that's what's going on. Because I have not been yawning and it just started all of a sudden. But I enjoy this topic. Like I'm not bored. I don't know. I think it's just my posture was making this. Okay, so the antiderivative, I think we got the same thing. We evaluated, we say the antiderivative when x is 2 minus the antiderivative of f when x is negative 1. And they got the same answer, 6. They did the exact same thing. Okay. All right, let's do another one. Let's try another one. We have a quick check. I'll leave that as an exercise for you. Okay. So let f be any continuous function over the closed interval a b, and let capital F be any antiderivative of f. Then the definite integral of f from a to b is going to be this guy. So this is the integral as x goes from a to b of f of x dx, which is going to be the antiderivative of f when x is b minus the antiderivative of f when x is a, right? So this is another way of articulating what we literally just did in a previous example. Okay. Let me see what's the time. Let me check on you guys. We're missing some people. Okay, well. All right, let's keep going. So we're asked to evaluate this. Okay. So we take the integral, right? The integral of x squared is going to be what? X cubed over 3. Again, normally we would say plus c, but we just want to evaluate this as x goes from a to b. So then this is just going to be b cubed over 3 minus a cubed over 3. And that's it. Yeah, and again, I hope everyone had a great weekend. I don't know, my weekend's like, I've been like zen as of late. So like I have like a movie pass. So AMC has this thing where you can purchase a movie pass, and I just, as a Christmas gift for like me and a few people, I got that for us. And so what that basically is, they have a thing where you can get a pass for the year. So I was like, yeah, bet, let's do it. So that was just my gift to like a few people or whatever. And so what it allows is like it allows me to see like 3 movies a week. So when what's his name, Kong came out, I saw that movie and then I saw another movie, but I was like dozing through Kong. Not that it was boring. I don't know. I'm always in the movie and they just be so comfortable. So I get so sleepy. So I went on and saw King Kong again that same day. So I saw it twice. That's the first day it came out. Because again, I get 3 movies a week. So that's kind of what I was doing over the weekend, just watching movies in the theater and just zenning out. I didn't do my run, so I felt bad about that. It's like I have to lock that in. Like I usually try to do like a 10-mile run, at least a 10-mile run, or it's not even really 10-mile run. It's more of a 10-mile run walk, mostly walking, but just try to be out there. But I feel way better when I do stuff like that. Like if I start to neglect that thing, it leads to trouble. Let's see. Yep. Here it is. All right, this is what we got. Okay. So yeah, but what we have is fine. Okay, let's keep going. So evaluate each of the following. Do I have enough space here? I think so. Let's try to work it out. So the first one, x cubed over 3 minus x squared over 2. Okay, and we want to evaluate that as x goes from -1 to 4. Okay, I might not have enough space. So when x is 4, 16 times 4 is 40 plus 24 is 64. So that's 64 over 3 minus 16 over 2. It's going to be a -1/3 minus 1/2. Okay. Let me see. What's a 10? Let me just use my calculator. Okay. Okay. Let's try this again, because okay. Let's see. I think what I'm actually gonna do, and you know what? I think there's a way that this can actually evaluate intervals, and I'm gonna try it right now. If I go to my y equals, let me see if I hit x squared minus x. Okay. Let me see. Is it here? Okay, number 7. Nope, nope, nope. That's not what I want. Math. I think this is it. Function integral. Let me see. Let me see if I can get this to work. If I go to variables, so y1, we want to evaluate that integral in terms of x as x goes from -1, nope, -1 to 4. We're going to see if I type that in properly. I'll get an error if it's not typed. Uh-oh, looks like we got it. Okay, so we got a result. Now, let's just confirm, right? I'm just going to type what we have on the end and see if we get the same thing. Let me hit math as a fraction. Okay, so then I just want to check. So I'm going to go 64 over 3 minus 16 over 2. Okay, then I'm going to say minus a -1/3 minus a half. Then I'm going to say math as a fraction. Okay. Okay. So, we can evaluate it, right? The calculator did it pretty much from here. If I hit math as a fraction, right, 85 over 6, right? So now we have a couple of ways to do it. 85 over 6, paste. Obviously, you want to be able to do these by hand. And, we don't always have the luxury of using the calculator in this fashion. We were able to do it in this one because we were evaluating the definite interval, right? We had those -1 to 4, right? So we were able to use the calculator. Let me do something similar for this next one. So the integral of e, let me see, is itself, and just check by doing a derivative, by taking a derivative. If it doesn't work out, you might have to divide by the coefficient of the power, right? But I think we're okay here. And we want to evaluate this antiderivative as x goes from 0 to 3. So this is going to show up as e cubed minus e to the 0, right? And then whatever answer that is. Okay. So then e to the power of 3 minus e to the power of 1. Okay. Sorry. E to the power of 0. Okay. So then here we get approximately, we can say 19.09. Okay. And then I'm just going to check it by putting the whole thing into the calculator, since we're able to do that. So if I go to my y equals, I have what? E to the power of x. Okay. Let me go back to the home screen. I'm going to recall what I have from before, because it is in y1, it is in terms of x, but it says x goes from 0 to 3. Okay. And we should get 19.09. Yep, we got the same thing. Nice. You learn something new every day, boy. Like, one of my mentors would say, when people would complain like you're boring, it was like, no, I'm not boring. He was like, only boring people get bored. He was like, I had to sit and think about it. I was like, damn, he's right, because I will never be bored. My students, I know you guys be bored. Like, I know you might be bored, and I do my best to try to bring some funk or whatever, but it's so interesting. Like, how can you find this boring? It's like, it's not boring. It's not trivial. But I'm not going to lie, I do remember sitting in math classes and, like, I don't want to be like I was bored. I just didn't understand. Like, I didn't know what they were getting at. And, like, again, I really feel like you can't get it until you have to sit with it yourself. You try to pick up whatever you can for whatever I'm sharing, but it's not until you can sit with it yourself and get intimate and you figure it out with, either by something I said or, something somebody else says. That's when it kind of comes to life. You know, but the whole moral of that story was the thing that he said was, only boring people get bored. And when I thought about it, I was like, damn, yeah, because I don't never really be bored. Even when I'm in a boring situation, I just know how to, like, keep myself mentally occupied. And then you start to find mystery and wonder in, like, every little thing. Anyway, assume that x is positive. Okay. All right, let's try this integral. Okay. So then here, the integral of 1 should just be x. 2x should be x squared over 2. So that would be 2x squared over 2, which is just going to be x squared. Okay. And let me show this so that you know how I'm getting this. Oops. This is it's really 2x squared over 2, and I had already, like, canceled these guys out. Right. I think the integral of 1 over x is ln of x. So minus natural log of x. Okay. Normally we would say plus c, but because it's an indefinite integral, it's a definite integral, we want to evaluate this antiderivative as x goes from 1 to e. Okay. And again, x is positive because the ln of x, because, we can't take the log of negative numbers. So then when we plug in e, we're going to get e plus e squared minus 1. And then minus, when x is 1, that's going to be a 1 plus 1. I think the natural log of 1 is 0. Okay, so that's just a minus 2. Okay. So then we'll use a trusty dusty rusty calculator. I'll evaluate what we have first, which is this e to the power of 1 plus e squared minus 1, and then we can say minus 2. We get this result. 7.107. Right, it's an approximation. So then let's just confirm that we get the same thing when, we type it in. Let the calculator solve it, right? Yeah, I think we're okay. Let's try it. So 1 plus 2x minus 1 over x. Okay. And then we just want to call on the integration. So we want to integrate that function where, for y1 in terms of x, but as x goes from 1 to e. So we want a 1 here. Let me just insert e to the power of 1 here. Okay. We don't really need the fraction. Will it work? Yes. 7.107. Okay. So, you know, we took the integration, we did it by hand, we crunched the number, we got this result, and we put it directly into the calculator, we got the same result. Okay, and this is a TI-83 plus. Sorry, I feel like my voice is a little hoarse, but you know, just kind of maybe if I drink some water, give me just a moment. I left my pen at the table this time, so I'm less likely to drop it and repeat last time. Like, I feel like mistakes are okay within reason. I think it's just important, especially as long as we can learn from our mistakes, or even better, if we can learn from other people's mistakes, right? Just try not to make the same mistakes over and over. If you can help it. Sometimes it's unavoidable. All right. Let's keep moving. They got a fraction. What did we get? 85 over 6. 60, 24, 84, 85 over 6 is correct. 19.086. 19, that's fine. Same rounding. Yeah, so we're good there. All right. All right, let's see what else we have. Quick check I leave for you all. Okay. So the fundamental theorem of integral calculus. If a continuous function f has an antiderivative, capital F, over a closed interval AB, then the limit as n goes to infinity, as I goes from 1 to n of f of x sub I times delta x, is going to be the integral as x goes from a to b of f of x dx, which is the antiderivative of f at b minus antiderivative of f at a. And so what this is, like, when we first introduced the integral, we kind of did it with like these, we had a curve and we broke the curve up. And like the first one may have had like 6 subintervals, and then the second one had 12 subintervals. And so we saw it, we kind of know that day we kind of ran long because calculating those subintervals was a little tedious. But the point of that was that the more subintervals we take, the better our approximation is. So then what this is talking about is now we want to push it to the limit. To the limit. I got that montage, 80 montage music going on. But no, we want to push that concept to the limit. You know, the first one we had 6 subintervals, then we had 12. Could we do 24 in the next one? Maybe 48? Like push it to the limit of like how many subintervals we can take. That's what this first part is taking. So now we will let the number of subintervals go to infinity. Right? Like at first the n may have gone to 6. Then in the second example, n was 12, and then 24, then 48, and then, you know, just let it go to infinity. And that's essentially what the integral is. That's what we're saying that the integral is. If we somehow could push it to the limit of those subintervals, essentially what we're describing is the integral of our function, which is also the area under the curve, or approximately the area under the curve. You know, that's essentially what's going on here with this slide, right? So suppose that y is the profit per mile traveled and x is the number of miles traveled in thousands. Find the area under this curve over the interval, the closed interval from 1 to 4, and interpret the significance of this area. let me see. The curve is profit, so the area should be a rate, right? Like, usually we start with, well, yeah, if we have acceleration, the derivative of that. So if we start with the position function, we take the integral and give us a rate, then acceleration. So if it's asking for the area under the curve over the closed interval from 1 to 4, basically take the integral and then evaluate the integral as x goes from 1 to 4. That's all it's saying. And then what is this telling us about this narrative? Profit per mile traveled, and x is the number of miles traveled. Why am I getting acceleration? I'm getting that it's kind of like the rate of change of the velocity or whatever, something like that. Anyway, let's go ahead and find this integral. So we want to evaluate the integral as x goes from 1 to 4. It looks like it's just dx over x, right? 1 over x times dx. So I think that's natural log. So that's going to be the natural log of x as x goes from 1 to 4. So then that's going to be the natural log of 4 minus the natural log of 1 is 0. So it's really just the natural log of 4, whatever that result is. Uh, 386. What are these units? I was pausing because I was trying to profit per mile in dollars. I'm getting that it's like profit per mile squared in thousands, but let's just see how we interpret this. Or what are the units here? Okay, 1.386. We're good there. Oh, that's it. Suppose that y is the profit per mile. Find the area, interpret the significance. Well, I don't see what I was looking for, but we did get that result, so that's good. Okay, let's keep going. Okay, so the area represents a total. Oh, is this okay? Okay, this is what I was looking for. The area represents a total profit of 1386.30 when the miles traveled increases from 1,000 to 4,000 miles. A total profit of 13. So this is in thousands. 1386.30. So to move it to the right 3. Yeah, 1386. Okay. So this is tell us the profit when we travel from 1,000 to 4,000 miles. Okay. Okay, that makes sense. So this, yeah, because again, the result these are in like thousands of miles or thousands. Yeah, it's in thousands of miles, so you got to say times 1,000. Okay. Okay. Yeah, this is what I was pausing. I was just trying to figure out how to articulate this, but that's what I was looking for. Okay. So consider this integral. Predict the sign of the integral by examining the graph and then evaluate the integral. Right. So if the I don't know orange or red orange, whatever that color is, the part that's below the x-axis, it looks like it's more of that than the part that's above the x-axis. So then you would anticipate the overall final sign, the overall result to be negative, right? Because more of the graph is below the x-axis for the region in question. So then evaluate the interval. Okay. So I am tempted. Can I break that up? Like I'm totally tempted to like I want to evaluate it from here to here and then here to here. I want to break it up, but not that we can't find these numbers. I feel like they're not going to be clean numbers. Like if we knew these numbers, then we could just break it up. So I'm just going to evaluate it as x goes from -1 to 2. And we are anticipating a negative result, right? So let's see if that happens, okay? So let's see. So we have the original integral there, so I'm just going to pick it up here. Okay, so the integral of x cubed is going to be what? X to the 4 over 4. So that's going to be a negative x to the 4 over 4. The integral of x is going to be x squared over 2. So that's going to be 3x squared over 2. The integral of 1 is just going to be an x, so that's going to be a negative x. And we want to evaluate this as x goes from -1 to 2. Okay. 16, so that's a -16 over 4 plus 12 over 2. Okay, minus 2. Then we're going to say minus, it's going to be a -1 over 4. So many negatives at play there. Plus 3 over 2 plus 1. Okay. Let's go ahead and get everything to a denominator of 4. So we can leave this one at 16 over 4 plus 24 over 4, 8. So minus 8 over 4 plus 1 over 4 minus 6 over 4 minus 4 over 4. What is that? 24, that's 34. So it looks like it's 25 minus 34 is a -9 over 4. So that at least confirms we at least got our negative. I'm going to use my calculator and see if I get the same result, just to confirm or deny. All right, they just check our work, right? So I'm going to go to y equals. We got this negative x to the power of 3 plus 3x minus 1. Okay. I think this is okay. And then I'm just going to call on what we used from before. We want to evaluate the function as x goes from -1 to 2. Okay. And we got our fraction thing. We should get, hopefully we get our -9 over 4. Woohoo! -9 over 4, right? So more of the graph was negative. We got a negative result. We didn't really have to do much different. We didn't have to do anything different or anything. So, okay. Okay, let's keep going. All right. So from the graph, it appears that there is considerably more area below the x-axis than above. So therefore, we expect that the sign of the integral will be negative, which is what we said. And then if we evaluate, we got a -9 over 4, which is the same as this guy. Realizing that was 0 would have helped out a lot. But it's okay. We got there, so that's all that matters. Oh, okay, so this example says Northeast Airlines. So this is just a current event, a little bit gossipy. It's just a wild story. The whole thing with, I don't know if you've been heard the whole narrative of the Boeing planes. If you have to fly on a plane in the near future, just check what kind of plane you're getting on. If it's Boeing, I would recommend you not get on that plane. So I don't know if you heard the whole narrative. Some years in the past, Boeing got a new president or whatever, whoever it is over everything. And they were willing to sacrifice quality of the planes to maximize profit. But I'm like, if you're in a plane and you're flying, obviously you want the planes to be safe, but they were like cutting corners. And so like now that's why you're hearing all these like planes like literally falling out of the sky, almost like wheels falling off, doors coming off, windows shattering mid-flight. And like for like by the good grace of God, I want to say with all these things that's been going on, nobody's like dying or anything, but that's terrifying. Right? You're like, oh man, the plane is falling apart, engines exploding, mid-flight. But again, it comes back to this thing of whoever the new management was, um, they were willing to sacrifice the quality of the planes to maximize profit. And so, like, the story goes a little further where there was a whistleblower that was coming out about that whole narrative. He was the former, like, quality specialist or, quality, person, the person over the quality of the planes. And he kept trying to warn them, like, yo, y'all are cutting corners, but this is dangerous. Like, these planes are going to fall out of the sky. This is not right. But, he alerted them and they ignored it. And so I think he was like on trial. He was like testifying, and I think he did like one day of testifying against Boeing. And then like that night he was about to go back home. Like he was in his hotel and he was packed up. And he was getting ready to leave, and Boeing called him and was like, "Well, can you stay for another day of testifying?" And he agreed to it. And so he had contacted his loved ones. Was like, "Look, if I disappear, I am not suicidal. It wasn't me. This, that, and the other." All right. And sure enough, the next day he didn't make it back to that second day of testifying because he somehow officially they said that he committed suicide by shooting himself twice, right? In the chest, something like that, something stupid. That clearly it was not suicide. Um, you know, but it was deemed as a suicide. But everybody knows that he was offed by Boeing. Um, allegedly, because I am on YouTube, so I do have to say allegedly in case anybody comes listening. Um, and so the last part of the story is I think that finally, through like pressure of society or whatever, that leader of Boeing stepped down. Now, personally, I feel like it should go further, but I guess you have to find some way to officially pin that person's death on Boeing and who's responsible. But it's just I don't understand how these people of like power and influence are just killed and like nothing happens. Like whether it's the CIA or whoever, like Bob Marley or the guy that invented a car that was powered by water, clean people that's making inventions with clean energy. I'm like, how is it that like these people are just killed and nothing happens? They're poisoned. I'm like, it's what are you supposed to do with that? When somebody comes forward that's revolutionary, it's constructive, it's healing for a society, and they get off. But if somebody's promoting like chaos in these rap songs and stuff like that, they're promoted and they're showered with money because it encourages people to self-destruct. It's stuff like that like irritates me about America. Um, and it's not the people, it's the officials. I'm like, well, do I need to like I don't even know if running for office is the right thing because I'm going to be trying to put things in order, and I know my efforts are going to be undermined and sabotaged. So it's like, how do you navigate that? How do you get around it? How do you like put things in order in spite of all the sabotage? You see what I'm saying? Like that's the whole conclusion of that Boeing story. That's the little rabbit hole that it takes me on. I see the clock. We got a solid little over 20 minutes. We're actually almost done with this section. Let me just kind of focus and get through this. I just thought it was an interesting. It was relevant because we're talking about planes, right? So it's just like I just wanted to share that. You can research all the stuff I mentioned and confirm or deny the narrative or whatever. It's just a interesting story. That and then like Diddy running, escaping and all this other stuff. I'm like, man, these are some wild times. I don't know what's gonna happen on this eclipse next week. I don't really think anything is gonna happen because we've had so many eclipses. I don't even know what the plural of eclipse is. Is it eclipses or eclipses? But whatever it is, we've had so many of them in the past. I'm like, why would this one be different? But it is kind of weird though. I will say that there's some weird things that's going on because schools are closing for the eclipse. They're supposed to be sending out the National Guard. I'm like, why? What's so special about this one? Why are they doing all this stuff, this hoopla and fanfare for an eclipse? So that's the only thing that makes me nervous. Is like they're closing schools. Is when they did the same thing in like Maui. They closed the schools for Maui. You know, don't get me started on that thing and how Biden is involved in it. That's like so disgusting. So anyway, enough of all that. I'm telling you, it's like some wild stories. Like I couldn't make this stuff up. You couldn't make it up if you were a writing for a movie script, right? Like Leave the World Behind with President Obama and the oil tanker crashing into the bridge. That happened like 2 or 3 times since that movie has come out. I'm like, come on. Are we like watching the movie? Or are we in the movie? Come on. It's so wild. It's so interesting. So anyway, that's enough of all that stuff. Let's get back on task. So we have Northeast Airlines determines that the marginal profit resulting from the sale of X seats on a jet traveling from Atlanta to Kansas City and hundreds of dollars is given by this guy, right? Marginal profits. Let's see. Resulting from the sale of X seats on a jet from Atlanta to Kansas is given by this. So this is the marginal profit. So we have a profit function. We take the derivative. That gives us a marginal profit. Find the total profit. So basically, they're asking us to take the integral when 60 seats are sold. So this is X goes from 0 to 60. Right? We might have space to do this. I'm going to start it over here. Right? So if this is the marginal profit, they gave us the derivative. They want the profit. They want the original. So it looks like they're asking us to take the integral as X goes from 0 to 60 of this function, square root of X minus 6 dx. Right? I think that's what they're asking. Okay. So if we have the integral of X, the square root of X, right, that's the same as X to the power of a half. So we add 1 and divide by that new power. So it looks like it's like X to the power of 3 halves over 3 halves minus 6X. Okay. And we want to evaluate this as X goes from 0 to 60. You okay? All right. Oh my goodness. What's going on? You okay? I'm busy. Ow. Thank you. Sorry, my dog is I don't know. She's being a dog. Okay. So if we let X be 60, right, we can say what, 2/3 times 60 to the power of 3 halves. Right? We can just do that. Minus 6 times 60. And then when X is 0, I think all those other terms cancel out. So we just need to evaluate this. Okay. So let's see. I think I'm going to do 60 to the power of 3 halves. I'm going to say divided by 3 halves. Okay. Minus 6 times 60. Okay. 60 seats, right? It looks like we're in the hole. Let me see. Find the total profit when 60 seats are sold. It looks like we're in the hole. Let me see. Hundreds of dollars. So we're in the hole by what, like $5,000? Is that right? We're getting a negative result. Right. So this is in hundreds. It's like we're in the hole by like about $5,000. Let's see. And like we might need to sell more seats to break even. Yeah. So when 60 seats are sold, Northeast profit is a negative $5,016.13. That is, the airline will lose $5,016.13 on that flight. All right, so they need to sell more. Yeah. What time is it? Oh, okay. Let me try to wrap this up. Quick check is an exercise for you all. Particle starts out from some origin. Its velocity in miles per hour is given by this, where t is the number of hours since the particle left origin. How far does the particle travel during the second, third, and fourth hours, or as t goes from 1 to 4? I mean, it's kind of a repeat. You just take the integral as x goes from 1 to 4, and then you get your result. I'm moving forward because we're kind of out of time. Okay, well, yeah, we need to wrap up. Okay, so that was pretty much area and indefinite integrals, right? So it's the same as what we were doing before. We were taking the integral, but we have endpoints now. So we're evaluating the integral as x goes from a to b. Before, when we didn't have that definite integral, then we added on the limit, the integral, the constant of integration, right? But because we have these endpoints, then the constant of integration essentially is gone, right? Okay. Are there any burning questions before we go our separate ways? Let me share. I'd like to send this to box. Let me get into the right folder because I know that's not the right folder.
Yes, I have a question.
Yes.
So for the question where we had done negative x square root to the fourth, and then for
Do you know which
what
example?
question after the one you just did?
I'm going to start scrolling once this bar goes away and then just tell me when to stop. Let me see. So I know we didn't do 7 together. 6. Yeah, we did 6. If it's not this one, just tell me when to stop. 5. With this one, the negative.
Yeah, it's this one.
Okay.
How did you get negative 16 over 4 and then 12 over two?
Yeah. So if you can get to this part here, right, we took the integral and then we're evaluating the integral as x goes from -1 to 2. So first we plug in when x is 2. If you plug in when x is 2, you'll get this result. Then we say minus, when you plug in when x is -1, you get this result.
Okay, makes sense.
Yeah. And then from there, it's algebra. Okay. All right. So you all have a copy of everything that you saw me writing. You have a copy of it. You can access it in Blackboard. And if there aren't any other burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, we only have 3 sections remaining of new material. All right. So we'll on Wednesday we'll do whatever the next section is. I think it's whatever the next one is. I can't think of the number. And then next week is the last of the new material. After next week, you can anticipate exam 2. Exam 2 is going to cover chapters 3 and 4. But keep in mind, you can't really do chapters 3 and 4 without using information from chapters 1 and 2. But it's an emphasis or a focus on chapters 3 and 4. Just like exam 1, online, unlimited attempts, all that kind of jazz. Okay, and so if there aren't burning questions, we're going to go ahead and end the session here. From one beautiful mind to another, enjoy the rest of your evening, and we'll meet back on Wednesday, same time, same place. Take care, gentlemen. Peace. Let me check Zoom one more again. Let's see. Ooh, let me try to get these gentlemen. Martin, Neil, and Evans. I think Martin was here and he just probably got booted. Yeah. Okay. Let me let him know. Yeah. All right, gentlemen. If you're just joining, I'm going to give you attendance credit, so you don't have to worry about that. Just let you know that you got credit. Because I think after that 15-minute mark, I just zone out or whatever. All right, gentlemen. Enjoy the rest of your evening. Take care.